Today we are going to be looking at our new unit that focuses on similar figures. So you need to take out your notes, and on the next page of your notebook, go ahead and label the top as SOL 7.6 Similar Figures. If you need to pause it real quick to get caught up, that is okay. What it means to be similar is when you have two shapes that are the same shape, but they are different sizes. So I'm going to write that down as my first definition. Similar means the same shape, different sizes. Same shape, different sizes. And what I mean by that is if we had triangle ABC, and if you remember from 6th grade, we can always label our figures by using their vertices, their points, like we just did in our last unit. So we have triangle ABC. On my paper, it takes up 2 lines. Well, if I were to come over here and draw a similar triangle, it would look very the same. It would just be smaller. I'm going to name this one MNO. And because they are similar triangles, I use this symbol in between them. I'm going to use it looks like an equal sign, and then you just put a squiggly on top. So this tells me this symbol ABC, triangle ABC, is similar to MNO. And I'm even going to write that down here. Triangle ABC is similar to triangle MNO. Once again, if you need to pause and get caught up, do that before we continue moving on. Now, to be similar, something that has to be the same, it's pretty cool, is that your angles, it doesn't matter if you're a big triangle or a little triangle or other shapes. We can do it with trapezoids, we can do it with pretty much any quadrilateral as well. Your angle measures are going to be the same. So I'm going to make note of that down here, that the angles have the same measure. So angles have to have the same measure. They have to look the same. And by the same measure, sometimes they will actually give us a number. So sometimes you're going to see a figure, and we'll go ahead and do a different color. Say we have the trapezoid, or we'll go back to that triangle. Even if we have that big triangle and the little triangle, they obviously look different, but it would tell us that if this is equilateral, all of our angles are 60 degrees. Even though this one's small and I can't really even write it inside, because I know that they are similar, which we set up top, I know that all of the angles are the same. Once again, you can pause if you need to get caught up. Another way of showing it is not having the numbers, but is using a symbol. So over here, I'm going to draw 2 trapezoids. If you don't remember a trapezoid from 6th grade, it is a 4-sided figure that has one pair of parallel sides. The top and the bottom on this particular one are parallel. So I'm going to draw 2 of them. I'm going to make them similar. Even though I didn't put letters on them, we're going to use symbols to show that they are the same. And to do that, we're going to use what we call little angle measures. It's a little like, it's kind of a swooped line almost. But to show that this angle is the same as this one, because they're in the same spot, I'm just going to put one little mark. Well, I also want to show that this one is the same as this one, so I'm going to put 2 little lines in each of those. I want to show that this angle corresponds, or rather is the same as that one, so I'm going to put 3 little swoops And I used the different number of them to show that they match up with each other. 1 always matches with 1. 2 always matches with 2. 3 matches with 3. And 4 matches with, I know it's very hard to draw, but there should be 4 of them. And because these are my notes and I want them to help me, I'm just going to kind of make a side note to myself that says the lines show that the angles are the same. If you need to pause again, go ahead and pause until you get your notes caught up to this point. So just a reminder, we know similar, same shape, different sizes, using this symbol right here. The angles have to have the same measure. And there's one other thing that we can do, is what we have what we call corresponding. And what corresponds means is that the same spot is on the other shape. Like we know that this angle corresponds to that angle because it's in the same spot on the shape. We know that the one with 2 corresponds to this one. And we can also do it not only for angles but for sides as well. So I'm going to go ahead, I'm going to choose a different color, and I'm going to write my definition of corresponds. So corresponds and what corresponds, like we just said, it means in the same spot in the same spot on the other shape. So we'll still have to have 2 shapes and we'll have to be able to match them up. So for this one I'm going to draw, once again I am going to draw actually 2 triangles, but they're not going to be equilateral. You'll see they're going to be a little bit more spread out. So I'm going to name triangle 1, triangle E, F, and G. And my similar one, I'm not going to make it as small, but it is smaller. It might not be perfect, but I know that it should be similar. I'm going to name this one X, Y, and Z. So if you need to pause now and get caught up, please do so. So corresponds, we said, means the same shape, just on the same spot, just on the other shape. So this time I didn't do my little angle lines like we did up top. This time I just have labeled with EFG and XYZ. But I know that because these 2 shapes are similar, that the line segment E and F, so to write line segments, we write those letters and we write a line right over top of them. E to F corresponds to, oh, I did not spell that right. So E to F, remember we said it has a line, corresponds to, and we look over on the other one, from the E to F, what's in the same spot is X to Y. They are in the same spot, so they correspond. I would like you to pause for a minute and go ahead and write 2 other things. If you'll do what corresponds to line segment F to G, so I'd like you to write that down. I would also like you to tell me what corresponds to X and Z. So if you'll take a minute, pause, answer those 3 questions. What corresponds to each of these line segments? So you should have got that F and G, I'm going to just abbreviate, corresponds to, if you look on the other one, from F to G is the same as from Y to Z. And then this time, I said for the next one, X and Z, well, we look, that's on our small one, that's okay. but from X to Z is in the same spot as E to G on my similar triangle. So we can go ahead and label that as the same. Since we went X to Z, I'm going to have to go E to G. Hopefully you're doing okay on that. At this point, you will need to go ahead and flip over to the back side, unless you just have a lot of room. And go ahead and pick up, if you have not gotten already, one. Okay, so on the back, we are going to look at how we can use proportions. Yes, I know proportions is something we did back before Christmas, but how we can use proportions to tell if two shapes are similar or not, because not all shapes, because they look the same, are actually similar. So you should have these 6 problems in front of you, and we can go ahead and glue those in if you would like. I'm going to glue mine. If you need to pause and get glue, go ahead and get those glued in as well. Okay, so using proportions to tell if things are similar. Well, the first thing is we have to be able to tell which sides of our shape are corresponding to one another. So for that, I'm going to get 2 different colored pens. I'm going to use pink and red, but I'm going to go ahead and circle. I can see that these are already set up the same way on number 1. So what I'm going to do is I'm going to circle. I can see that 35 corresponds to 14. And I can also see that 40, how it's along the bottom, corresponds to 16. So I'm going to take my first triangle, I'm going to even put a 1, triangle 1, and I'm going to make a proportion out of that. I'm going to put 35 over top of 40, just like we did proportions in the past. I'm going to put equals. Instead of having an unknown, though, I'm going to have 2 complete fractions. So I put my 2 of the same colors, the ones that corresponds next to each other, and then my 40 and my 16 next to one another. And now I'm going to use cross multiplication. So I'm going to multiply. I'm going to do 40 times 14, and you can use a calculator, so if you need to pause and go get one, please do. But I see that 40 times 14 is 560. I then also need to cross multiply here. I need to do 35 times 16, which is also equal to 560. When these numbers are the same, we can say yes, the shapes are similar. They are similar. If these numbers had come up different, we would have to say no, the shapes are not similar. Even though they look the same, they are not proportional to one another. Proportional means that you are similar. So I'm going to add that just up here. Proportional. So proportional means similar. If you need to pause and rewatch this part, make sure you understood what I was doing or get caught up, that is fine. So I'm going to look over at number 2 right now. And my first thing I'm going to do is I'm going to get those 2 colored pens, and I'm going to circle my things that correspond to one another. Now once again, these shapes are kind of set up in the same area. So I'm going to see that 24 corresponds over on this side. Uh-oh, I have a problem. There's nothing listed there. So while this will be okay, because 24 and 24, I'm not even going to use that. I'm going to use this 24 because I can easily see that it corresponds to the 16 because they're literally in the same spot on 2 different shapes. And then I can also see that the 18 corresponds to the 10. So those 2 are corresponding sides. So now again, I'm going to go to my figure 1, and then I have my figure 2. I forgot to do that. I have figure 1. And I'm going to go ahead and use figure 1 to create my proportions. I'm going to have 18 over 24. I'm going to put the equals. Now because the 18 was on the bottom, I have to do the number that's on the bottom, which is the 10. Plus I did them in the same color. And here I'm going to do 24 corresponds to 16. If you don't have different colors, maybe instead of circling, do 2 of the corresponding in circles and maybe go up and do squares around the other 2. You can be creative in how. I want you, though, to have a strategy of how you can tell what corresponds with each other. So I've got my proportions. I'm going to do that cross multiplying again. I'm going to do that 24 times 10, which once I get in my calculator, I see that equals 240. And then I can do my other side. I'm going to do 18 times 16. And I can see that that is 288. Well, this time we have a problem. Did we get the same numbers? We did not, so I'm going to put a big no here, as in no, they are not similar figures, because our things were not proportional. So no, they were not proportional. So then I'm going to go to number 3. Now number 3, if you notice, is a little bit weird, because if you look, our shapes, while they look the same, they are not aligned the same. The 7s has been turned. So we have to pay close attention to see what do the 7s match up with. Can anybody tell what they match up with one another? If you're hard visualizing, sometimes I just take the shape and I mentally just rotate it. We learned about rotations last week. And when I rotate it so that it looks like this one, I can see that my 25 on this one would match up with the 7 right here. And if you notice this time, so if you don't have different colors, I did squares. This 25 corresponds to this 7, because I had to mentally rotate it. If you can't see it mentally, then just redraw it. So I kind of take it, I'm going to take that slanted part up top here. I'm going to put the other parts kind of not perfect, but like this, and I'm just going to make sure where I rotated it, there was a 7 and a 7. So now my shape looks the same. If you need to do that, use that as your strategy. There's nothing wrong with that. So now let's take a look. We have, oh no, sorry, I didn't mean to do that. Next we need to make our fraction. So I'm going to have my 25. That since that matched up, over here I looked that it matched up with the, the 25 goes with the 25 equals, well over here I had the 7, this 25 matched up with the 7, and the other one matched up with the 7. I'm kind of getting a clue here. The numbers are the same. So I'm mentally seeing that if I multiply these, I'm probably going to get the same thing. 25 times 7 gives me 175. Well, 25 times 7 again gives me 175. So once again, they got the same number, so we're going to say yes, they are congruent figures. If you feel comfortable at this point, then you may go ahead and get the practice. If you do not feel comfortable, we will continue working out numbers 4, 5, and 6. So number 4, I've got a, same shape, definitely twisted weird. So let's go ahead and see. So I'm looking here, I see that I have a 35. It's slanted on top, it's just the opposite way, so it'll be okay. But my 35 is going to match up with a 42. And this 35 is going to match up with, if I actually flipped it, would match up with this 42. In this case, if you notice, it's been reflected. Imagine if you were to take this first shape and flip it, it would be reflected. So we would have those same thing, though. We have our 35 and 35 equals, over here we have the 35 and 42 and 42. This is very similar to the last one we did where they continue to, they're the same numbers, kind of gives me a hint. I think they're going to be congruent. I can do my math to double check, but because they're the exact same numbers, I know 35 times 42 is 1470 and 42 times 35 is 1470. I would like you to pause this and go ahead and try numbers 5 and 6, please. Even if you think you're struggling, give them a try, and then you can watch the rest of this and check it out. So for number 5, I have a 21 that matched up with a 14, or I should have made that a circle, excuse me. And we have a 21 that matched up with a 14. It looks like we're getting that same number thing again. So once again, it's looking like they're probably going to be congruent. So I'm going to do my 21 matched up with a 14 equals 21 and 14. So yes, they matched up with one another. So if I do my multiplying, I'm going to get 14 times 21, 14 times 21. I'll check with my math using that calculator, but I believe they both should equal 294, which means yes, they are congruent. So any questions? If you notice, we had this number 8, but we did not have a number down here. So that was extra information that we did not need. So we needed to get rid of that. We did not need that. And number 6, hopefully you've already done. If you haven't, pause it and do number 6. Ooh, I have 3 numbers again, so I need to figure out what matches up with one another. So I would need to mentally rotate this to know that the 18s would be on top where the 20s, and the 21 would be down with the 35. You can do your 18s and 20s. I'm going to try to use some different numbers. So I'm going to do that my 35 corresponds to my 21, and my 20 corresponds to my 18. Oh, and I circled the wrong one. Even though they're the same number, I really should use the correct one. So let's go ahead and set this up. I have 20 over 35. I got that from shape number 1. My second ones come from shape 2. So let's see, I have an 18 matched up with my 20. The colors were the same. And I had 21 went with my 35. So when I did my cross multiplying, I should have done 35 times 18, which gave me 630. And then my 21 times 20. Ooh, I got completely different numbers. I ended up with 420 and 630. So are these shapes, are they similar? They are not. They are not similar shapes. So at this point, I think you're ready to go ahead and get the practice sheet out of the folders. So you are ready to go.